Tell me when.
Go ahead.
Okay, so now what I've done is I've just covered up some of those beams. So hopefully now you only see one beam coming through. And instead of the D-shaped lens, I'm going to use this rectangular slab. And so what I want to do is I want to put this on here and just see what happens. So let me just turn the light out so I can see a little bit. I can turn the light back up in a minute if you need it. And so this shows you an interesting property right here. It's pretty faint, so I'm going to turn this light all the way off. Now, where's my ruler? Here it is. We see the main beam comes in, and there's a reflection off of the first face coming out this way. There's a reflection from every interface. Sometimes it's bright, sometimes it's dark, and it depends on the angle. So it's hard to see here. It's a little bit more faint because of the angle, but it is still there. There is a reflection off that front face. And that works. Angle of incidence equals angle of reflection. Let me turn this on for just a second. If I wanted to put this ruler here, you could see that beam is splitting, and the angle of incidence right here is equal to the angle of reflection. Sorry if it's too dark to pick up. Now, what we can do as well, however, is we could send this thing in at some weird angle like this, and now what we see, there's a reflection off the first face. Some light is transmitted. You could do Snell's law to try and understand that. But notice there's a reflection off the second face. It's not a total internal reflection, it's a partial internal reflection. And so some of the light comes right through. And in this case, notice, I'm going to turn the light on for a second. Notice that the incoming beam and the outgoing beam are parallel when you send it through a slab like this. So I'm going to go ahead and turn the lights down slowly so you can see that. I probably should get rid of this protractor since it has nothing to do with this experiment. Sorry about that. But now, whoops, let me rotate that so you can see it better. Okay, so we'll just kind of make it dimmer and dimmer.
It's looking good right there.
Right about there? Mm-hmm. And so, I don't know if the meter stick shows up, but if I could just try and show you here, we see that the incoming beam should have gone straight through. When it hits a rectangular slab, it refracts, and then it comes off parallel to the initial beam. Again, this requires you have a perfectly parallel set of faces. That's it.